Hi, my name is Nico Tuton-Filson, and this is Jackson Robinson. We are part of the Fisher Group Lab, and our presentation is on the installation and preliminary use of the Lunt Solar Telescope at Pine Mountain Observatory in Bend, Oregon. PMO has been owned and operated by the University of Oregon since the mid-60s, and over the past year we have been constructing its newest observatory, the Lunt Solar Telescope, to study the Sun. In the middle image on the left of our poster, you can see a red box, which is where the newest observatory currently lies. The Sun is a massive, ever-moving ball of plasma, and it might not look like there is a lot happening from the naked eye, but up close there is in fact a lot of activity on the surface and surrounding the star. This can be classified as solar activity, which ranges from dark spots on the surface to violent surface eruptions that throw radioactive material into space. Since scientists have been observing the Sun, we've concluded that solar activity occurs on an 11-year cycle, going from the peak level activity down to a very minimal level over that time span. This means that the quantity of dark spots and eruptions is directly correlated to solar activity cycle.
The solar telescope is going to be a permanent installation at Pine Mountain, and as such, needs a structure to protect it from the weather when not in use. Like most other small observatories, this structure consists of a dome that can be opened to view the sky and a platform for it to rest on. The platform was created by pouring concrete on the ground. We also added a raised ring to help the dome protect the telescope inside from the elements. The dome is then set on top of the concrete ring, and the telescope is mounted on a pedestal inside. With the telescope mounted and ready to go, we are now set to acquire an image. Unlike your typical camera, which creates an image by capturing a single picture, our system creates images of the Sun by taking a video and then stacking frames from that video to increase the quality of the final image. A solar telescope is similar to most other telescopes with one key distinction: a filter which blocks out almost all light from the Sun. Our telescope has a hydrogen alpha filter, which means that it only allows light that's very close to hydrogen's alpha line, a wavelength of 656 nanometers.
That being said, to finalize the installation of the solar telescope, it must be aligned with the North Pole. This has proven difficult due to the inclement weather conditions up the summit. Once the alignment and the installation are complete, we can move on to the final portion of our project,
which is automating our image processing procedure to allow a continuous image stream. These images will then be automatically uploaded to our website, ready to be viewed by the public.